Okay, so let's move now to the next presentation given by Stefan Scher on biases and bias and calibration. Please, Stefan.
Thank you, Felix. Good evening to all. I would like to give a short report on the IHS Bias and Calibration Working Group. So my name is Stefan Scher. I'm affiliated with Swiss Federal Office of Topography, Swiss Topo, as well as the Astronomical Institute of the University of Bern. And I'm moreover a member of the Code Analysis Group. The Bias and Calibration Working Group was established in 2003 with the following main overall goal. So it coordinates research in the field of GNSS, bias retrieval and monitoring, and it defines rules for appropriate, consistent handling of biases, which are crucial for a model mixed GNSS receiver, ground network, and satellite constellation, respectively. We work in close collaboration, in particular with the CLOC working group, because biases and clocks are, there is a one-to-one correlation. Therefore, we also have joint splinter meetings. Of course, the ionosphere working group there, in the ionosphere analysis, you also determine interfrequency biases, as well as the PPAR working group. So the main focus is on GNSS pseudorange biases. Was originally on GPS C1W minus C1Z using the RANXC naming, or P1 minus C1 biases. Here is a plot showing the values for the GPS constellation as a function of the various space vehicles for the various signals. So you also may notice here the different blocks, the different generations of satellites. That's the situation for GLONASS as well as Galileo. It's worth mentioning that we had two dedicated workshops, IHS Bias workshops, organized at the University of Bern. So one in 2012. You may likely recognize some faces here on the group photo. There was a second one in 2015. And among other things, we discussed and finalized the bias SINEX data format version 1, which confirms to be an important instrument for various applications, especially also for PPPAR. Let me highlight the following key achievements. So we are moving more and more from a DCP, so a differential representation, to a pseudo-absolute, what we call OSB, observable specific signal bias representation, which shows its advantages regarding multi-GNSS due to the fact of the multitude of different observable types and tracking modes. Another thing is the provision of phase biases for the PPPAR application in OSB form conforming to the bias SINEX seems to be becoming more and more established within the IHS. Concerning the future work, we are currently working at code to additionally generate and make available OSB values for all determinable intra-frequency code signals, such as, for example, GPS C2L soon. The consideration of the third signal frequency, for example, specifically L1, L5 for GPS, may be seen as a long-term effort for the whole IHS. So this is really then affecting many working groups. And here I listed also a wish from our side to remind that the possibility to connect the products from one day to the other is still a strong wish from our side. And that's the update from my side. Thank you.
Thanks so much, Stefan. Okay, I don't see any comment on the chat. My only one will be that again, it's quite impressive to see how all these activities are connected and how all these working groups are progressing all together. I mean, OSB and defining OSB, providing OSB for real time, for RTCM, for clocks, for consistent clock products, and so on. I mean, all these things are going together, and it's great to see that the organization is working so well, and is able to face so critical and difficult topics. So thanks again, Stefan.